Hello, welcome to video number 5. This is a continuation of assembly and also some other features of solid modeling. In the previous video, we created this solid hammer using a sketch, and also we created this hammer hanger. All this modeling was done inside a single Fusion 360 file. If you look at the browser, you may remember we had this symbol converted into this bunch of boxes from one single box. So this indicates this file is an assembly file. Inside there I got these components. If you want to assemble more components into this same exact assembly, you can always design some bodies here in the same drawing and convert them into components. But sometimes you're gonna need to bring the models from some other file and assemble them in here. So that is what I'm going to show you now. So instead of creating another body here, I'm going to design like a hammer head in another drawing. So I'm going to open up a new design by simply clicking on this plus sign. Then I get a new workspace here. So I simply go to sketch, select a plane, and start with a circle. I'll give it a diameter of 60. Finish sketch, right click, press pull, click on the sketch, and maybe 30, 40 will do. Okay, so notice I dragged from the arrow here. If you rotate this around, you're going to see another handle, another control I have here. Notice there's a like a rotation kind of a handle. If I grab and turn, what's going to happen here, you can change the draft angle, so the taper of it. So this is a very important uh, feature when you are designing something for injection molding, because you need to make sure the product you design is going to come out easily from your mold. So in this case, I just show you how it's going to be changed. In this case, I'll give a little angle, maybe 5 degrees, and you can leave it as a new body, doesn't really matter. Okay, so that can be used as our hammer head. Let's add some fillets as well. I can right click on the edge or easily go into the fillet button. So right click on the edge, press pull, does the same thing. I push it in maybe 7.5, and also in the uh, fillet control dialog box here, you can add new selection, and you can click the other end, can push it in maybe 5. So you can give in the same action, in the same fillet command, you can select multiple edges and also give different values as well. Notice when I say OK, in the timeline there's only one fillet feature, but if you double click on that, if you right click edit feature, you can see I got multiple. It really includes 2 fillets with 2 different values. Okay, before we take this component into the assembly, let me briefly show you how to change the appearance of this by adding a material. I will go very detailed on that when we discuss the rendering lesson. So what I'm going to do, I'll right click on this object and right click and go to appearance. Then the appearance window pops up here. So here it allows me to add colors or materials to different faces or just the entire component. So I'll select the whole component. Here I got already some appearances stored in the library. You can also go to cloud and find some more. Fusion 360 appearances, you got fabrics, glass, liquid, metal. Let me go to metal for now. Metal and how about bronze? So that will give you a bit of a contrast. Bronze, patina. Let's try that. Drag and drop. That's all you need to do. Just simply select the material you like, just drag and drop. That's going to gonna get added into the object. So if I change the visual style to shaded, that's gonna look pretty good. Let's try appearance. Let's try the shiny one. Drag and drop. Okay, I think that much better. I just added into one face. That looks much better. Look at the shine. All right, so close it. Now I'll say we created our hammer head. What I'm going to do now, I'm going to save this. Save. Then I give it a location and give a name. Let's say hammer head. Save it. So now that's saved in the location right here. We call it, it's in the Wesley folder in my data panel. Go double click, it's right there. So now I'm gonna go in, so I can close this file now. So when I go into my assembly, so far all these components are built inside this file itself. So now I go to data panel, find the object I want to add into this, right click on there and select insert to current design. Click on that. It might take some time to import into this file, and there it is. So now that added into there. So you can position it if you like, you can rotate it, if that really matters. But in this case, I'm going to directly assemble there into this hammer. So I'll say OK. One thing I would like you to notice here in the browser, notice there's a little chain mark saying that is a link. That indicates that particular object, when I click on that, it will highlight, is not built inside here. That is linking with another external file. Okay, let's go ahead and assemble this hammer head into the hammer. All right, so I'm going to click on joint. Then I'll select one of the faces in the hammer. Then when I go try to select the hammer head, okay, there's no reference in here to select. That's gonna be a bit of a problem because I can't find any proper reference in my hammer to align that with the new component. So I could select the edges, or I could select two faces and select this face and the other face. That will still be asking me to find another point as the second reference. So it doesn't really work on me in this case. So what I'm going to show you here, let me cancel out this and come out of this. I'm going to show you how we're going to isolate one of these components that built in this assembly file to make some changes during the process of assembling. Example, now I need to make a change in this hammer. How are we going to make that edit? So in that case, notice this little radio button here, activate component. So this button means now this whole assembly is active. But if you look at other components, if you hover over them, you can see all of them appear that button, but they are not active. There's anything that built in this file has this radio button. If I click on this hammer, click on that, now the hammer is active. Others are just appearing there in the background, but you can't do much changes in there. They happen to sit there. So now this is pretty much like the early stage of this file, and while we are designing this hammer. What I'm going to do now, I'm going to add a point at the end of this hammer, so we can use that as a reference when you're going to assemble the hammer head into that. But the problem is, this is not a face I can select and make a sketch on. It's different from the other flat faces here, because this is an organic shape made out of a spline. if I try to do that, let's see, I go sketch, and nope, it doesn't allow me to select that hammerhead. I finish sketch and right click and delete this one. And there's no plane here either. All the planes are intersecting on this origin here. If I make the origin appear by clicking on this eye symbol, there you go. So those are the planes. So you can make sketches on a plane or a face. So what I'm going to do is I'm going to create another plane here. So basically make an offset plane of this particular plane on this level. So now that way I can create an artificial canvas. So that is done through construct offset planes. So I click on this construct offset plane. Now it's going to ask me to select a reference. So I'll select this plane here. So because this is an origin for the hammer, select that. So in this case, I'm just going to eyeball it because I just need a rough location for the point, because I can adjust the in the joint how they're gonna come together. Make sure go into a view that you can clearly see the intersection. Move it further forward. I think 35 does a very good job. So it's like almost on at the edge. So 35, okay, that's fine. Click on OK. Now I created the new canvas, pretty much new plane. What I'm going to do now, just go click on create sketch, then select this plane. Now there you go, I'm ready to create a sketch on that plane. So look at again, sorry, oops, there you go. All right, so I can see, okay, that is where the hammer head is. I'm gonna go create and point. That's all I want. Click on point. So I'm going to use this mesh to guide me. That seemed to be the symmetric position right here. Just give it a click, finish sketch. That is all I want. If I rotate around, now I can see I have created a point. I'm going to use that as a reference here. So now simply what I can do, I go to assembly in the browser, I click on this radio button and activate the entire assembly. But that dot, it's going to be there because that was done in the process of assembling. Alright, so now I got the hammer head. I can hide the origin. Good. Alright, so now I can go to join, click on this face, and simply click on the point. Alright, it came to a okay, was like that. You can simply click on this flip button. It's gonna flip the side, and you can push it back how you like, and it's quite a bit of out of proportion, but no big deal. Say okay. This gives me another opportunity to show you how the editing and updating works. So what do I mean by that? So so now I already show you how to make a edit on one of the components that designed inside this same file. But this hammerhead was done somewhere else and it's linked. So you can always go into that file. So you can go to that file by right clicking that particular component in the browser, right click and open. Then you can see the background. There it is in the background. So that file opens up in a new tab. So what I can do now, I can simply go to the sketch, right click, edit sketch. I can reduce it by simply double clicking and maybe go to 45, enter, finish sketch. Now that's automatically updated. Also, I can change the extrusion as well. Edit feature. 45, 40 seem to be a bit too much. 35, yeah, it should be okay. Done. So now we make the change and I can save it as well. And the other beautiful thing I can show you here is Fusion is keeping track of the changes you make. And you can also give some explanations of what's the change you make in that particular revision. So in this case, I make size reduction, and so say do OK. And when you go into this data panel, now we can see it's updating now. Notice what happens here. It's updating. You can see it's turning, and now it's V2. It was V1 before, now it's V2. If you click on that, it tells me what are the changes. So the first version, item created. The second version, size reduction. It tells you the timestamp as well. So it also tells you users and used in, what documents we have used in. So probably I didn't have it saved there, that's why. So this is the history. It shows me the version history and everything inside the data panel. So let's go into assembly file. Look what happens here. Even though I saved. Let me save this one and no, that's not there. See, I got this warning saying that this is this component out of date. There will be a warning appear here as well sometime soon, saying that this file got the message that this particular component has been updated, but it's not updated in this file. So we need to do it manually by right clicking on the component and go get latest. Click on get latest and notice how that change going to reflect in the model visibly. Get latest, and it's happening. There you go. Now that looks perfect, isn't it? That's a hammerhead. Nicely done. Okay, so in this assembly, even though I just put this hammer and the hammerhead together like that just to match up with the locations here, assembling two parts together in real world, it takes some process. So either welding or using some fasteners like nuts and bolts. So I looked at some of your concepts and I realized some of your designs might need that sort of hardware like nuts and bolts. So I'm going to show you how we going to mount this hammer hanger, assuming that gonna get mounted into the wall. So let's go ahead and work on that part. So in that process, I'm gonna hide this hammer by simply clicking on this eye and not that one, hammer and the hammer head, and directly I'm going to work on this part now. Okay, the process of mounting this hammer hanger into the wall. My plan is creating 4 holes in these 4 corners and using 4 countersink bolts to put through this block and tightening to the wall. Alright, so if you haven't heard of countersink bolt before, wait around. In 5 minutes you're gonna learn that. Those nuts and bolts, so they have some standard sizes, and we shouldn't have to design them from scratch because they must be available because they are standard things that you can buy from hardware. Luckily, Fusion 360 has a built-in library that basically it's a connection with uh, a supplier called McMaster-Carr. So McMaster-Carr is a leading fastener or hardware provider in United States. So they have built in their inventory here, you can basically use all their CAD designs of all these equipment, all these little fasteners, and also you can buy through this app as well. But I'm not sure how the purchasing is going to work when you select them from here in Australia. uh, at this point, let's work on how to download a CAD of a countersink bolt. So first of all, when you go to this find search bar, I'll go bolts. Okay, so then I get different types of bolt. So hex head, socket head, and rounded. We call this a button head as well, rounded head screws. And these are the ones we called, alright, so it's a flat head screw, and this head is a countersink. Let's go select that, flathead screws, and then we select what sort of screw head we like. So let's go ahead and select this flathead screw. So in my case, it is important for me to the screw is flush with the face. So that is the reason I go with this countersink. All right, so in here, I'm not going to be very specific here. Because in my case, I just need a graphical representation. But if you're working for a carefully calculated advanced project, you might be worried about some of these properties. Example, the technical details here. Select. Let me go ahead and select the thread size. I'll go with M6. That has a 6 mil width on this threaded body. And also the length, I think 25 mil will do the job. Okay, so then I have a certain bolt type has been selected. So I go to the product detail, follow these instructions if you want to download a CAD file. Then this will have all the technical details, the pressure it can take, and most of the technical details for a designer will want, and the pricing as well. Pack of 50. Oh, not bad. Then when you scroll down, you're going to see information of the 3D model. Okay, you get to select the file type. I don't want the SolidWorks. I will take the step. So STEP, the step file as a kind of like a generic file type, step or IGS. So they are 3D files that can be used by any CAD platform. So I'll go with the step 3D and save. Then what happens? That bolt magically going to appear in a second, boom, like that. So that is the bolt I just selected. You can uh, position it as how you like, but in this case, I'm just gonna click OK because I will position it through a joint. All right, so now that we got uh, this bolt imported, let's make the hole. So that is a very important task. You're learning how to create holes in this face. You already know how to use the extrude tool. You can use the extrude tool simply. You can not with this, you can do a sketch on this face, okay, and make a circle with a given diameter, and you can simply click on this new sketch, right click, press pull, and select that sketch, push it inside and say okay. That's just a hole, that will do the job. Yeah, but we need to learn a bit more advanced than that. So I'm going to undo that, get rid of this sketch. I'm going to show you how to add a proper hole, that means standardized hole that is designed for a specific fastener. Alright, so that is done through this hole feature right here. So I click on hole, then I get to select placement. I got multiple or single. So I'll go with single for now. Then face, I will select that face. Oof, then already picked up some dimensions, but let's not worry about that. Before that, I forgot it. I need to measure some of the features of this bolt here. Alright, so this is a good example for you to learn the measuring tab. How do you measure some features here? You may have seen this already, this measure tool, which basically does the measuring, of course, right? So click on the measure tool. Now you get to select different features of this. I'm going to select the outer diameter, and that is 11 millimeters. Okay, close. And also we go select uh, this edge right here, that is 6 millimeters. Okay, so now I have a rough idea that uh, what are the dimensions to provide when the hole feature is asking me then. Holes. Okay, so I'm gonna select, okay, that face, and reference. Okay, reference from, you know what, I'll do that later on. So hole type, I'll select countersink. See, if you look closer, you can see the differences here. This is a simple hole. This is not much different from just a simple extrude what we did before. Then the counter bore, it's basically for a socket screw, because it's like a cylindrical head, you remember, so that can sit in there, still giving you a flush head with the face. The countersink is actually, there's a 90-degree uh, connection with these two faces, and this is much more I think it takes less material off, so most of the designers prefer to use this design, this type of bolts. So let's go with countersink, and then this other dimensions. Okay, so the width of the the diameter of the head, that was 11 we measured. Then this was 90 degrees, of course, this countersink. Then the body width. So actually let's have this bit more than 11, so that it can nicely sit in there without having hovering over that. And the width of it, we can have 6, but it's going to be a very tight fit. In my case, this is not the face that's going to be threaded. With this, the threaded face going to be the wall behind this block. This block is just will not be a threaded face. It will be just a hole. So I'm going to have a clearance of maybe 7 mil. That will do. Okay, so now I go to the reference. Then it comes for the placement. I'll go look at it in a perpendicular way. Good. References. I'll select this edge. From there, I will take, that's 20, so maybe 10. Okay, 12. 12. Then the second reference from that face, I'll take it 15. Done. There it is. That's my countersunk hole. Okay, so the next job is bringing this one in there. So that's simple joint, isn't it? So go to joint. What I'm going to choose this conical face here. That conical face gonna get aligned with this conical face, and boom, there it is. Just click OK. That's a nice assembly right there. Okay, so now this is ready to go to the wall when we have 3 other bolts here. In the next video, I'll show you how we use the mirror tool to simply mirror them across the other 3 positions. So like, rather than just doing all these steps all over again. And also there are some other features I want to talk to you about, like revolving, patterning, some other features that I think that will be important for your projects. All right, so I'll see you in the next one. Thank you very much.